Bill has an MRI. That's why he's coming. And he's not going to be here tomorrow.
Okay, so I hear we're gonna talk about. Yesterday we talking about how to graph polar, graph and paddle rose curve, and if you're graphing the rose curve, that you don't want to plug in every single coordinate, which is we did that yesterday. If you were here, it will look something like this. It will look something like this. Basically, we just plug in each unit circle value into the things, and eventually it's gonna get the radius, the pole, how far the distance away from the pole. Now, if you plug each individual thing is in there, you'll figure out what happened here, and you'll get a paddles. And those rose paddles is gonna be symmetry in some way. So today we're gonna say instead of plugging all those values, is any way we can plug in like half of the value. If we can plug in half the value, then we can actually do things much more efficient. Which is last class we actually talked about the symmetries.
Is there any chance you can change it so we can have full screen?
Yeah. So in here, that if you have a polar axis symmetries, so there would be x-axis. So you basically replace the data with negative data. A long time ago, we learned how to do even odd function. It looks like this. You plug in negative x to find out either even function or odd function. If you go back to original state, then it's going to be even function. If you go back to the opposite original, then it's going to be odd functions. So, and same thing we're going to do here. We just want to see if we go back to original function. We can replace the data with negative data. If they come back to original function, that's going to be a symmetry to polar axis. If you did the line equal to data over pi over 2, which is you replace the data with negative data or r with negative r, if you go back to original functions, then that is going to be the symmetry to the line of data equal to pi over 2. Or you can do lastly the pole, the origin. So you just replace r with a negative r, see what happened. If you go back to original, then that's going to be symmetry to pole. Symmetry to pole is like a long time ago, it's like even a function. It's like origin, because pole is an origin. So you can do a following few things to test it out. So for example, this question's here. R equal to 1 minus cosine data. First of all, we can plug in negative data.
Is this new? New equation?
Yeah, this is a brand new equation. Oh. I want to see what kind of symmetry are they, if you can figure out.
No, I did not. Things were not drawing circles. The graph is circle stuff. No. Clover.
Now, do you guys know cosine is even or odd function?
In general?
Cosine is even. Thank you. Think about cosine graph, right? Cosine graph is going to be even. It's like this. It's symmetry from the y-axis. So it's even. Okay, so it's even. So even is going to be fine here. This is even. So that means I plug in negative data, it's going to go back to original cosine of data. So if I do that, I plug in negative data in there. I go back to original state. If it go back to original state, this is symmetry to what?
Wait, does the negative data just not matter?
Yeah, it will change it to positive data.
Symmetry, like,
because of both sides of the graph are exactly the same. If you plug in negative data, it's going to be symmetry to the y-axis. But sine is going to be, if you plug in negative data, it's going to be negative sine data.
Okay, so for a cosine, it doesn't matter because you already know what the graph looks like.
No, if I just think about if I have cosine graph, right? So
Yeah.
it's going to be cosine of x. Cosine of x
Oh,
right here.
I understand.
So if I plug in negative x here, does that change? Right? If I do parenthesis here, it doesn't change.
Oh, okay. Now, yeah, I'm thinking about.
So
that
if
and
I
that's
plug in
also-
cosine of negative data, it's going back to the positive things. So this one just symmetry to polar axis. Polar axis is the x-axis. So that means you can graph half the graph and you can just copy it. Okay. We can also test other symmetries. So the other symmetries plug in negative r and negative data. If I do that, what will happen? It'll be negative r equal to 1 minus cosine data. Now, if I multiply both sides by -1, then I'm actually get opposite than original functions. So if I getting opposite, that means they're not symmetry to data equal to pi/2.
So you plug in negative data and then plug in negative r to check each thing.
Yeah. At this case, if you want to see if they are symmetry to pi/2, you plug in negative r and negative data and see if it go back to original state. If it go back to original state, that's a symmetry. And last one, I'm going to plug in negative r. If I plug in negative r, it's going to get exactly opposite than original state, so it's not symmetry to the pole. So basically, they are only symmetry to polar axis. Polar axis, which is x-axis. And if you graph top part of the graph, then you can draw the other top bottom part of the graph. It's not really symmetry. It was a pretty bad job. It was like more like this. So because you know the symmetry. So this is a specific type of shapes. There is a name for those type of shapes. There are a lot of different names. They are this one is Limacon.
A what? Sorry?
Limacon. Limacon, I think. Limacon.
Because it looks like a lima bean.
Maybe, I don't know. No idea. So this is called Limacon graph. There was a graph like a other things. So you can try out, see if this function is which type of symmetry. Let's see. I'm gonna give you one to try. So r square is equal to 4 sine 2 theta. So you can see which kind of symmetry is this. You gotta try 3 different things. Are they symmetry to polar axis? Are they symmetry to the line of pi/2? Or are they symmetry to the pole? Sometimes you can have neither, all 3. You're not symmetry to any of them.
Okay.
Mr. Ye,
Mhm.
when we're plugging in pi/2, so we're definitely with symmetry.
No, you're not plugging pi/2. You plug in r with a negative r and data with negative data. If you are testing the symmetry, the line equal to pi/2.
We're plugging negative theta and negative r.
Yeah, and see if it go back to original state.
And if either one of them do it, then it works.
Or
No, if both of them do it. Then.
If the result of that equation go back to original state, then that's gonna be it.
But it has to
Let's think about
work for
this.
both
Pi/3.
negative theta and negative r.
Yes, for the line data equal to pi/2. For polar axis, you just have to replace data with negative data. For pole, just replace r with a negative r.
Wait, is that every time though? Let's see. Pi over 6? That would be pi over 3. Negative. It's just negative. That's an interesting thing. If you ever have a negative on the inside of the entire argument, you can move it to the outside side. No, you can't. Could you?
No, because
What?
polar axis
Or equals 4 sin. Oh yeah, he did do that.
But it wouldn't be symmetrical.
It's negative. Think about
You
it.
just
How
plug
we-
in the values and see if they're the same.
Yeah.
So like with the cosine one, the reason they're the same is because cosine of like negative pi over 3 is the same value as cosine of pi over 3. You get what I'm saying? Because like it doesn't matter if you move like up or down, they're both this measurement. But with sine, it's the vertical thing. So if you move up, it adds a positive value, and if you move down, it adds the same value but negative. So they're opposites.
So let's replace
This one's gonna be a sideways.
negative data. So r squared equal to 4 sine of 2 of negative data. If that's true, that's going to be 4 sine of negative 2 data. Now, it didn't go back to original state. So this is not symmetry to polar axis. Now, I'm going to do it again. I'm going to replace the r and data at the same time. So r is going to be like this. And 4 sine of 2 negative data, that's going to be r squared equal to negative 4 sine 2 data. So it's not symmetry to the line pi over 2 either. So this is the first try, this is the second try. I'm going to do the third try. The third try is going to be see if it works. I just replaced the negative r, I believe. So negative r squared is equal to 4 sine 2 theta. R squared equal to 4 sine 2 theta. And that's it. This is the one that's symmetry to the pole. So symmetry to pole.
So why don't we just, the order just seems odd to me, like, isn't it like if 1 and 3 both apply symmetrical, then 2 is symmetrical. If 1 doesn't apply,
I'll be back from A1.
Yeah, usually will only work one symmetries. Because the pole is actually do it twice. They are symmetry twice. They are symmetry. First of all, is you look at XQ graph, right? So they are third quadrant graph. It's gonna flip up and then flip over again. So it's a double flip. So that's our functions. And I just realized that I think Rubik cube works really similar ways.
Why would you do the second test where you make them both negative? Because if you do the other two, wouldn't you get like the same result?
No, the second result is not conclusive. It's not symmetry. Right? So what you're gonna do is you can draw a half of the graph. If you do the symmetry test, you can draw half the graph and then just reciprocate to the other side. So you don't have to plug in as many value. Imagine that
What would symmetry to pole do for you though?
it's like if you draw it's literally that graph's gonna look like this. I'm gonna tell you what it look like. It looks like this. That's it. Because symmetry to the pole. So this side is gonna copy to this side. That's it. So that's what exactly that graph look like if I do it to the other side. So imagine that I have to plug all this stuff in, right? That's a lot of work. But I know that if I plug in halfway, if I got into here, right? This is the two things. And I can say, okay, I want to see if there's symmetry to this. I can plug in negative r and negative theta. If I do that, I'm going to get negative r equal to negative 4 sine 2 theta. And that's true, so that I'm symmetry to pi over 2. Then I can just copy the other side, and I'm done. I don't have to plug in like another 16 values, or not 16, another 8 values probably. I don't have to do that anymore. I can just do half and copy the other half. So those symmetry is very, very useful to see, which line is symmetry to. Got it? Okay. So with that being said, I'm going to talk about one more thing, is how to take a derivative of a polar equations. Okay. So we just finished a pre-calc. Pre-calc is that's a pre-calc level to build onto the calc level. But yeah. So pre-cal level, we're gonna go with we know how to sketch the polar graph now, but I want to talk about one more things though. Do you guys know why even one it will show up double and odd one will show up just exactly same petal? Remember we did that yesterday?
You plug that in decimals.
Yeah, so let's just do like R equal to 2 sine of theta. Let's see what the data is.
But do you put like A?
Yeah, so we put a let's just say we do 1 here is 1 petal, right? If I do 3 is 3 petals. If I do 4 it's double. Now, do you guys understand why? This is something that I didn't realize this last year too. 3 petal. I mean, I realized this last year, but I didn't realize that that's the reason why. If it's 3, if it's odd, then you only have shows exactly odd thing. So what happened is they trace the same line twice.
Like there are 6 of them, but they're over top of
Yeah, they are over on top of that. So be careful when you're doing the finding the area inside the paddle. You don't want to do 0 to 2 pi. If you do 0 to 2 pi, you actually doubled it, the area.
Oh wow.
Because this first paddle like you draw like between 0 to pi is already give you the same thing. So let me show you, let's say between 0 to, I don't think they can change this. I think they have an option here on the bottom, but they cannot change it. But this is 0 to pi. 0 to pi is already formed 3 paddles.
I think you could plug in like a different, instead of plugging in data as a variable, maybe you can plug in like
Oh no, hold on. Let's do 2 pi.
oh, there it is.
Yeah, 2 pi is still the same thing. But if you do pi, if you do pi over 2, you guys gonna see that, right?
What should
At pi over 2, you already.
That's
Okay, so let's just pi over 6. I'll show you pi over 6. Pi over 4. Actually, let me do it in term polar. That way you can see it a
that'd be
bit
cool
better.
if there were like drawing channels like on YouTube and like they
Okay, so
make
pi over 3, right? Pi over 3 is 1 paddle already. Do you see that? And pi over next one is pi over 2, I think. That's half of 3 paddles. And let's do 2 pi over 3. So 2 over 3. That's finished 2 paddle already. So you see that a pi is going to give you exactly 3 paddles. So when you want to find area inside of things that you don't want to do 0 to 2 pi, even though it seems like this is went down to 2 pi, but it's not. So let's go to the even one. I'll show you the even one. So even one is 2, right? But do you see that 0 to pi only finish halfway, right? So 2 is going to finish the fully. So those are the things that you have to pay attention when you guys, especially baseball play, you guys are not here. Next week we're gonna talk the Thursday and Friday, and you guys are gonna have to watch it or listen. I'll try to do the best job I can.
We'll be here next week.
But Thursday and Friday, we're covering this on Thursday and Friday.
you said this isn't symmetrical across the polar axis, right?
Yeah, so this is interesting. You can only have one symmetry, and the reason why symmetry is if you do halfway, is that symmetry to the pole? It's not, because if symmetry to the pole, you only do halfway. So all you need is this one. We find out if we plug in. I think this one's symmetry to y-axis, which is pi over 2.
Yeah.
So if you plug in, I think you have to plug in negative r and negative theta, and then you can reciprocate the other side. Does that make sense?
Yeah.
So then you can copy and becomes 4 paddles. But the thing is, you're gonna argue this is also symmetry to pole axis, or you're gonna argue this is also symmetry to polar. But it's not symmetry if you just do halfway. You want to see halfway and see what a symmetry of.
Can there only ever be one?
So in this case, only y-axis, not x-axis. Because if you do x-axis, then it will be the same two petals there.
Yeah.
Do you see what I'm saying?
Yeah,
So yeah.
that makes sense.
So yeah, I didn't know that I can do this. Now I'm just learning new tricks too. So which is good.
That was kind of crazy.
So I'm going to take the equation on that's I want to see what our is squared.
Wait, that's literally the angle.
Here.
Okay. So you get ready to take some derivatives.
Okay, so what I'm gonna do is I'm gonna talk about, let's take a derivative. So we know how to sketch a polar graph, and then you're gonna say, okay, well, can I find the tangent line on a polar graph, right? The tangent line we know in Calc 1 is dy dx. It's very intuitive. It's very intuitive. So dy dx, but the problem is we don't have Andrew. Yeah. The problem of that is we actually gonna go with dy d data here over dx over d data, because if you keep change flip, d data would cancel. Now there is an equation for this, but I usually don't remember this equation. Myself don't even remember this equation. So you know what, I'm not even bother with it, because you can always derive those equations. Let's just say, hey, I want to find out the equation tangent line at, I want to find dy dx. Find dy dx when the data is equal to, let's just say when it's equal to pi over 6. Okay, let's just say it's pi over 6, right? For r equal to sine theta. So this is the equation. This is the polar equation I come up with. R equals sine theta. Obviously, this is probably some type of circle, because you can r square both sides. You can r times r on both sides. Remember last week we said we can times r on both sides, and you got r squared equal to r sine theta. Then it's going to be x squared plus y squared equal to y, and then move the y over. You can complete the square. You can figure out the equation. But now I say, hey, can you find dy dx when theta is equal to pi over 6? But we only give you r equal to sine theta. Now remember, this is a polar equation. Now if it's a polar equation, can I figure out what my x is?
Yes.
What is x?
What is
R
Okay.
is r, right? And then cosine of x, right? Cosine theta, right? And what is r?
Sine theta.
Sine theta, cosine theta. Do you see that?
X equals sine theta cosine theta.
Hold on, I'm trying to think about this.
What's a y?
Oh, okay.
The r cosine thing is just how you convert the points, remember?
Yeah, that's the equation for you to convert.
Adjacent over okay, that makes sense. Yeah.
Yeah, and then we plugged in the function where r equals sine of theta. We plugged that in for r in this specific problem.
Okay, that makes sense. Thank you.
So in this case, it's going to be sine theta times sine theta, which is sine squared theta.
1 minus cosine squared.
Yeah, that's true, but you don't need that.
I know.
But you might need it later though. It's good that you're thinking of that, because we need it when we deal with integrals. When something was too complicated, then we know how to do it. So obviously, I can take dx d theta here. So I can take a derivative with respect to theta. So here is what kind of rule I'm thinking of? Product rule. So it'd be cosine theta times cosine theta, and minus sine theta,
Yeah.
and that's also known as cosine squared theta minus sine squared theta.
That's one of the rules.
That's one of the identity. Which one is that? It's very important you know that because it make your life a lot easier.
Cosine of 2 pi.
Huh?
Sorry, cosine of 2 theta.
Cosine 2 theta. It's double angle.
It's that one that no one believes.
Okay, so how about dy d theta?
Hold on.
You gotta give me a second to catch up.
Is this chain rule?
Yes, that's chain rule. Good
So
job.
wouldn't it be 2 sine theta times cosine theta,
Perfect.
which is sine of 2 theta?
Sine of 2 theta.
That's the one I like.
But what is it? What is dy dx now? Well, that's just basically sine of 2 theta over cosine 2 theta, right? And that's equal to what? Tangent 2 theta. So I can plug in pi over 6. So tangent of 2 times pi over 6. That's equal to tangent of pi over 3. And which is, that means square root 3.
This is way more complicated than I thought.
It's just gonna take me a minute.
So slope is going to be pi over 3. Or square root 3. When the angle is at pi over 6. Okay, I'll give you, what is r equal to sine of pi over 6? What is that? R equal to what? Half, right?
Yeah, square root 3.
So remember at half, comma,
Okay.
pi over 6, then my dy dx looks like this.
That makes sense.
1/2.
You can actually convert this to rectangular form.
What is it? R comma. What's the thing for
R comma theta.
yeah.
So if I got 1/2 and pi over 6, right? If I got 1/2 and pi over 6, that's my polar coordinate. What's my slope of respect to dy dx? It's gonna be square root 3. That's it. At the same question, I can also find out
What's that arrow to the right?
which one?
The one that's pointing straight down.
I don't know. I lost a train of thought when I'm doing that.
So wait, that's tangent line?
No, that's a slope.
The slope of the tangent line.
So for example, this is some type of graph looks like this. This is some type of graph look like it's a circle. Like this. And at around half and pi over 6, this slope is gonna be, this slope is equal to square root 3. So at this particular point. I don't know if I draw it correctly, but yeah, it's gonna be square root
That
3.
makes sense.
So the function tan of 2 theta would be like the general statement for the slope? Like
Yes.
You could plug in any value. And
Yeah, you can plug any value. Or you can evaluate one at a time. Like sometimes you can plug in sine 2 theta, which is the question I'm giving to you next, is you have to find out that. One more things before we go is this. If you want to find horizontal tangent, basically dy d theta is equal to 0. If it's a vertical tangent, is dx d theta equal to 0? So let's just say if I want to find out this function r sine of theta, wait, hold on a second, r equal to sine theta, I can figure out x equal to sine theta cosine theta, and the y is equal to sine theta sin theta, I think, and the x, well, dx dt is what? Product rule, which is end up to be cosine 2 theta, and this dy dt d theta is equal to sine 2 theta, guess what? I can solve for 0. If I solve for 0 for the first one, it's gonna be a vertical tangent. So vertical tangent occur when dx dt d theta equal to 0, which cosine 2 theta equal to 0. Does that make sense?
Which is that pi over 4?
Which is at we don't know. So when is the cosine equal to 0? Pi over 2 and what? 3 pi over 2, right? And I'm gonna divide it by 2 on both sides, so it'll be pi over 4. And theta is equal to 3 pi over 4.
That makes sense. Only got one.
And guess what? Those are square root 2 over 2 and pi over 4. Because if I plug in the theta, then I will get square root 2 over 2. If I plug in this one, it's going to square root 2 over 2 and the 3 pi over 4. And this is where the vertical tangent occur.
And you can find the horizontal ones by doing it with sine of 2.
Exactly. So 2 theta equal to 0.
Makes so much sense.
2 theta equal to, I think pi. And this one's 0 and theta equal to pi over 2. And then you will get 0, 0. And 1 comma pi over 2. This is your a horizontal tangent.
That's way easier than finding them in the non-polar way.
Okay. Wait, the time's up?
Yeah, we have like. Yeah.
Okay, so I'm gonna tell you this is the first question of your homework. You should try it immediately if you have time, but if you don't have time, come back. And I will post also, your homework is gonna be a lot today. You have to go back and redo that test. So I'm gonna send you a copy of that test online on Canvas.
On top of their homework?
Yeah, if you fail, right, which is most of you guys, which is I'm gonna give you answers. You guys just have to find a way to get to the answers.
Oh, sick.
So getting us the answer is
Yo, guys, we got the answers
There
to
was
the
one
homework.
time where
I thought we got it.
you not post
So we have like regular homework and
Oh, oh.
So I'm gonna post the answers right now with the thing. So I'm gonna just write down the answers here.
It was, I remember before the test, like before our last test, that you posted like a fact, right? And you said you're gonna have answers with them.
Yeah, the answer is usually like right here. I give it to you guys and stuff like that. But no, I probably didn't.
Can you post like a PDF of the test instead of like pictures so I can like print it out?
Yeah, I'm gonna do.